Okay, Pure 1, October 2019, answers by the one and only Miss Hayden Higgins. I know, isn't this wonderful? Okay then, so question number 1 looks nice and easy. It's only 5 marks, okay? So, figure 1 shows a sector AOB of a circle with centre O and radius R. The angle AOB is 1.25 radians. Given that the area of a sector AOB is 15 centimetres squared, find the exact value of R. So first of all, how do we find the area of a sector? Okay, we know if we're going to find the area of a sector, we would do theta over 2 pi multiplied by pi r squared, okay? Obviously, we'd cancel pi, so the formula is theta r squared over 2. Okay, so they've told us that our angle is 1.25 and our area is 15. So we're going to get 15 equals 1.25 multiplied by r squared over 2. I need to rearrange this, so I'm going to get 30 divided by 1.25 equals r squared. How am I going to find r? I'm going to square root it. So I'm going to get the square root of 30 divided by 1.25 is 24 equals r. Now normally we do plus or minus, don't we? But you know, we can't have a negative length. So we've got positive root 24. We can actually simplify that because 4 times 6 is 24. So root 4 times root 6. Which is simplified to 2 root 6. So there we go, it's in exact form and it's also simplified. So then part B says, find the exact length of the perimeter of the sector. Write your answer in its simplest form. Okay, when in doubt, draw it out, okay? Always draw it. If you think perimeter, we're going around the outside. So for the perimeter, we need this part and we need this part. Okay, straight away we know this is 2r. So this is 2r. Plus, we then need, let me get the highlighter. We then need this arc length, okay? Now again, how do we find arc length? Well, we know it's going to be theta over 2 pi multiplied by, and it's 2 pi r. Okay, so again, we're going to cancel 2 pi and 2 pi, so it's just theta r. So our formula that we're going to have is 2r plus theta times r. Okay, we know what r is, we know what theta is, so we can literally substitute everything in. So we're going to get 2 lots of 2 root 6 plus 1.25 lots of 2 root 6. Again, it said the exact area. So 2 lots of 2 root 6 is 4 root 6. 1.25 times 2 root 6, which is 5 over 2 root 6. And when I add them together, I'm going to get 13 over 2 root 6. And again, we have simplest form and it's exact. Now, don't forget, this is also centimetres. Okay, because we've worked out the perimeter. Nice and easy, 5 marks. Yeah, if you write 13 root 6 over 2, that's also the same thing. Okay? Right then. Question 2. So, I know that we've had a bit of debate in class because some people have solved it a variety of ways. The simplest way to probably solve this question, we'll read it first and then we'll go through it. Okay, a tree was planted in the ground. Exactly 2 years after it was planted, the height of the tree was 1.85. Exactly 7 years after it was planted, the height of the tree was 3.45. Given that the height, h meters, of the tree, t years after it was planted in the ground, can be modelled by the equation h equals at plus b, where a and b are constants. Okay, so it has given you a formula and it's told you what everything is. Really what it's looking for is simultaneous equations. That is what they're trying to edge you towards. Because in the first question, We have 2 years, okay? And remember, t is years. So in the first one, we've got 2 years. Second one, we've got 7 years. Okay, in the first one, it's told us the height is h. So we've got 1.85 and 3.45. If I was to fill this in, we're going to have h is, for the first one, our height is 1.85 equals a lots of 2 plus b, because we don't know what a and b are yet. And then for our second one, we're going to have 3.45 equals a lots of 7, again, plus b. Now, when I'm substituting, I'm writing this in, but again, we are mathematicians. So I'm going to have 2a plus b equals 1.85, and 7a plus b equals 3.45. Now, it's clear to see that we can take them away from each other because they both have a common b. Okay, so then if I do the second equation minus the first equation, 7a minus 2a is 5a, b minus b is 0, 3.45 minus 1.85 is 1.6, so that means that a equals 0.32. Then to find b, I'm going to substitute this back in, 64, so that b equals 1.21. So now we found the values of a and b. Again, you can double check this by putting these two values back into this equation to make sure it makes sense. Part B says, state according to the model the height of the tree when it was planted. Okay, so we want to know the height of the tree when it was planted. If you think about this, this is essentially an equation of a straight line. Okay, because what we have here is the height equals our a is 0.32 lots of our t plus 1.21. Okay, so if we're thinking about this, we have our time and the height of the tree. This is an equation of a straight line, y equals mx plus c. So you can think to yourself, where is the y-intercept? Because that is when our t equals 0. Okay, so there's a few ways you can look at this. When t equals 0 is when it was planted. When t equals 0, our height of our tree was, in fact, here, which is 1.21. Now, again, always bring it back to the context of the question. And the question says it's in meters. So it's 1.21 meters, okay? Please make sure that you write that down. I will accept 121 centimeters as well. So, in this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Okay? It's very important that you read this. Just because you've got a calculator doesn't mean you have to use it. So, figure 2 shows a sketch of the curve C with the equation y equals x squared minus 5x plus 13. The point M is the minimum point of C. Okay, first thing we should be thinking, how do we find a minimum point of the curve? Complete square. Okay, everyone should know that. Okay, so the minimum point is C. The straight line passes through the origin and intersects C at the points M and N as shown. A, the coordinates of M. Okay, so we need to find the coordinates of M. So we need to find the coordinates of the minimum point. So what am I going to do? I'm going to complete the square. So we know that y equals x squared minus 5x plus 13. So we're going to get x minus 5 over 2 squared minus 5 over 2 squared plus 13, which is going to give me x minus 5 over 2 all squared plus 27 over 4. Okay, so the coordinates then are going to be 5 over 2, 27 over 4, okay? Now, these are split into a half and a quarter, so I do know that actually we are going to have we could, if we wanted to, write it in decimals. We can have 2.5 and 6.75 because realistically, you know, I always say leave it as a fraction, and do always leave it as a fraction. But if, you know, if you simplify your fraction and it is a 0.5, you know, to have an understanding, you can just write them down. But if it's, you know, 10 decimal places, no, leave it as a fraction. If it's only 2 and it's exact after 2 decimal places, then yeah, either or, okay? Part B, find the coordinates of n. Okay, well, first of all, what do we know? We know that m and n are on the straight line. They're on the same straight line. If we know the coordinates of m, and we know that mn passes through the origin, we've got 2 sets of coordinates, do we not? Okay? So, we can find the equation of the straight line. We then know that n also happens to be on the equation of the curve. So then, what can I do? I can put them equal to each other. Okay, there's a few different ways to do this. It is worth 5 marks. Okay, so then I've got 2 points and I'm going to work out the equation. So I know I've got the origin, 0, 0, and I've got m, which we know is 5/2 and 27/4. Okay, so to find our gradient, we're going to do y2 minus y1, which is just 27/4, divided by x2 minus x1, which is 5/2. So our gradient is in fact 27/10. Okay, now we've got our gradient. We know that y equals mx plus c. Our c is the origin, so it is literally just 27/10x. Okay, perfect. We now know as well that n lies on the same straight line as also lies on the equation, so I can put these equal to each other. So 27/10x equals the equation of the line, which is x squared minus 5x plus 13. So I'm going to get x squared minus 5x minus 27/10x plus 13 equals 0, okay? So then what do I get? X squared minus 5 and 2.7 minus 7.7x plus 13 equals 0. It clearly says do not use technology. If anybody now used their calculator and did your ABC, you're not going to get the marks. Okay, it's very clearly written here, isn't it? So we can either do 2 things. We can try and factorise, okay, or we can use our quadratic equation. To be honest, these aren't whole numbers. I'm not going to factorise, okay? I'm going to use the quadratic equation. So I'm going to write, oh, wait there. Solutions relying on calculator technology. Oh.
You can use the quadratic. You can plug in the value. You have to write down the quadratic and then you can use your calculator.
Okay, let's see what the mark scheme says. Yeah, I think, okay, so that mark scheme actually, believe it or not, factorises this, but I think if we show that we're using the quadratic formula, then that will also be okay. So A equals 1, B equals minus 7.7, and C equals 13. So we're going to have minus B plus or minus the square root of B squared minus 4 lots of A lots of C all over 2 lots of A. Okay? So, x equals 2.5 and x equals 5.2. Okay? And I just realised another way. We're being very silly, everybody. So, we missed this. We obviously know one of the solutions is already 2.5. So we know if we factorise, we could have done x minus 2.5, and then we'll be able to find out our other x. Yeah. So that's really silly, isn't it? Because we just need to do 13 divided by 2.5, because obviously we know that these two numbers are going to multiply to give you 13. So we could have just done 13 divided by 2.5, which is 5.2, okay? And we could have gone back and we could have said how many 2.5s go into 13, okay? The other way to do this is really, you know, how many, we could also say this is the same as saying how many 25s go into 130, okay? If we multiply both by 10. So actually, been a bit silly there, but I'm not sure if this would be accepted. I'm not sure if the quadratic equation would be accepted. Okay, let me double check and come back to you all. So please make sure that you look at this. Okay, so we found our answer. So x, the coordinate of n, we know x equals 5.2. How do I find y? I'm going to substitute in 27 over 10 lots of 5.2, which is going to give me 14.04. So our coordinate is 5.2 and 14.04. Perfect. Right then, part C. Use inequalities to define the region R. Okay, well, nice and simple, actually, because the curve here, have we shaded above or below the curve? Below, so we want less than. So we know then that y is less than, and the curve is x squared minus 5x plus 13. Okay, and with a straight line, did we shade above or below the line? Above, so we want y is greater than 27 over 10x, okay? And again, if you're not sure, when in doubt, work it out. You can try a coordinate that's up here, okay? That you know will be up here. So, or below. You know that 3, 1 would be in here. So, okay, so you could try that coordinate and see what happens, to make sure. Okay?
Isn't there a third inequality?
Isn't there the x?
Yeah. X equals 0.
Yeah, actually, there is a third inequality because we are going to have x
Just the third one is 2.5 is bigger than x.
X equals, no, x is greater than or equal to 0, because it's a solid line, okay, and what else do we know about, x is less than x squared minus 5x plus 13, but if y is less than that, and then we know that this m coordinate is also x is less than or equal, no, it's not less than or equal to, it's less than 2.5. So actually we can put these together. So we're going to get 0 is less than or equal to x, which is less than 2.5. And then we have y is greater than 27 over 10x. And we have y is less than or equal to x squared minus 5x plus 13. Okay, so again, make sure that you're really looking at the graph and what's going on. Perfect, so that's 2 marks for that. Okay, so as suggested, a bit more explanation. Bigger, more than the line is still up here as well. And then less than the curve is still all this bit. We need to make sure then it's between that m coordinate, okay, which the x value of that is 2.5. If you don't put this equation at all, you don't get any marks. Okay, a parallelogram ABCD has area 40 centimetres squared. Given that AB has a length of 10, BC has a length of 6, and angle DAB is obtuse, find the size of angle DAB in degrees to 2 decimal places. Okay, first of all, I cannot work this out without drawing it. I have to draw it. So we know it's a parallelogram. So A, so this is A. Oh, I'm on the wrong thing. B, C, and D. So we know AB is 10, BC is 6, DAB is obtuse. Okay, it's a parallelogram, so we know that these are all the same. Find the size of the angle D. How do we find the size of the angle? Well, it's told us the area. So if we split the area of this whole parallelogram in half, we can actually use a half AB sine C. So we know that a half AB sine C equals half the area, because we only want one triangle, so 40 over 2. Okay, so then we're going to get a half lots of 10 lots of 6 sine of the angle X, which we're trying to figure out, is in fact 20. So if I rearrange this, I'm going to get 30. So sine of X equals 2 over 3. Okay, if I find what X equals, so they want it in degrees, so make sure your calculator's in degrees. So X equals sine inverse of 2 over 3, which is going to give us 41.8 degrees. Okay, first of all, 41.8 is not obtuse. So we need to use our knowledge of the sine graph and symmetry. Okay, this is my sine graph, as awful as it looks. We know this is 180. So we know 2 over 3 is roughly here. So we're going to have 1 here and 1 here. So we need to do 180 minus to find the obtuse angle, which is in fact 138.19 degrees to 2 decimal places. Okay? So please make sure you show all of your work and you read the question to get the obtuse angle. Part B. Okay, so we know this is now 138.19. The length of the diagonal BD. Okay, what should we be thinking straight away? Cosine rule. So this is actually nice and simple. C squared equals A squared plus B squared minus 2BC cos of A. So we know what our C is, what we're trying to figure out. Our A squared and B squared, so 10 squared plus 6 squared minus 2 lots of 10 lots of 6. Cos of our angle, 138.19. Please make sure, 138.19. Please make sure that your calculator is in degrees. When I do this in square root, I'm going to get 16 equals 15.0 to 1 decimal place. And again, this is centimetres. Okay, question 5. The curve has the equation y equals x cubed over 6, we can leave that as it is, plus 4 root x, which we know is the same as x to the power of a half, minus 15. Part A, find the differential given the answer in its simplest form. This is dy by dx, nice and easy. Bring the power down, 3x and minus 1 from the power. Bring the power down, 4 times a half is 2x minus 1 from the power. Bring the power down, well this is x to the power of minus 15 goes to nothing. Now though, the 3 over 6 can be simplified. So we're going to get x squared over 2 plus 2x to the minus a half. Okay, finished. The point P, 4 and 11 over 3 lies on the curve. Find the equation of the normal to the curve at P. Well, we found the gradient function here. So the gradient function gives us the gradient of the tangent. So the gradient of the tangent to the curve is when we substitute in our x-coordinate 4 into our gradient function, which is 4 squared over 2 plus 2 lots of 2 minus to the power of minus a half. This is going to give me 9. If our gradient of the tangent is 9, so this is our tangent line, the gradient to the normal we know is perpendicular, so we need to do minus 1 over. Okay, so then the gradient of the normal equals minus 1 over 9. Okay, how do you know you're right? Well, the gradient of the tangent multiplied by the gradient of the normal should equal minus 1. Okay, now you've got the gradient of the normal, minus 1 over 9. You have a point, you have a gradient, y equals mx plus c. So y equals mx plus c. So our point is 4 and 11 over 3, and our gradient is minus 1 over 9 because we want the normal. I'm going to substitute this in. So 11 over 3 equals m minus 1 over 9 lots of x, which is lots of 4, plus c. Okay, going to work out c, which is 37 over 9. So I'm going to get y equals minus 1 over 9x plus 37 over 9. I'm going to multiply everything by our highest denominator, which in this fact is 9. So I'm going to get 9y equals minus x plus 37. It's still not in the form ax plus by plus c equals 0. I'm going to move everything to the left-hand side. X plus 9y minus 37 equals 0. It's also okay if you had minus x minus 9y plus 37 equals 0. Okay? Either or they will accept. But nice and simple question here. Preferably try and have your x and y's positive, but just in case you needed to do something else. Question 6. The curve C has the equation y equals 4 over x plus k, where k is a positive constant. Sketch a graph of C stating the equation of the horizontal asymptote and the coordinates of the point of intersection with the x-axis. Okay, so step 1, we are going to draw our axes. Okay, we know that the graph of 1 over x looks like this. Okay, it's a very terrible sketch actually, with the asymptote on the line y equals 0. Now it's plus k, so now if we imagine if we've moved it up k, okay, this is our coordinate k here. Okay, we're not sure how much we moved it up, but we know this is a transformation, and this is an asymptote on the line y equals k instead of y equals 0. We then know 4 over x, well, what's happened? We've multiplied it by 4, so we've actually shrunk it. So now when we are drawing this, it's going to look like so. And you can see here it crosses the x-axis. Okay, now this point here is minus 4 over k. So we also have minus 4 over k, 0. Okay, and if you're not sure how to work that out, you can substitute in the value y equals 0 into this equation and rearrange to find minus 4 over k, because this is when y equals 0 along this line here. It then says in part B, the line with the equation y equals 10 minus 2x is tangent to C. Find the possible values of k. So we know the line with the equation y equals 10 minus 2x is a tangent to C. Okay? So they must meet at one point. Okay? If it's a tangent, that means that they will share one point in common. For example, this would be the 1 point. So what we need to do is we need to put them equal to each other first, and then what we actually have here is a discriminant where we have to find the discriminant. So we're going to have 10 minus 2x equals 4 over x plus k. Now what I'm going to do is multiply everything by x. 10x minus 2x squared equals 4 plus kx. I'm going to move everything to the left-hand side, the right-hand side actually. So I'm going to get 2x squared, and then we're going to have k minus 10 plus k minus 10x plus 4 equals 0. Now what we're going to do is we're going to use the discriminant because we know the number of solutions to both of this is 1, exactly 1. So b squared minus 4ac equals 0. So our a is 2, our b is k minus 10, and our c is 4. So we're going to have k minus 10 squared minus 4 lots of 2 lots of 4. So we're going to have k squared minus 20k plus 100 minus 4 times 2 is 8 times 4. 32 equals 0. So k squared minus 20k plus 64 equals 0. So now we need to solve this. Again, you can put this into your calculator, and we're going to get k equals 10 plus or minus 4 root 2. So it says find the possible values of k. Now for this we do not have an inequality, so the answer is k equals 10 plus or minus 4 root 2. So essentially if you wanted to, you could write k equals 10 plus 4 root 2, or k equals 10 minus 4 root 2. Question 7. Figure 4 shows part of the curve with the equation y equals 2x squared plus 5. The point P, 213, lies on the curve. Find the gradient of the tangent to the curve at P. Okay, so we need to find the gradient of the tangent to the curve at P. But I know it looks like it passes through the origin, but we're not sure if this is true yet. How do we know to find a gradient function? Well, we can actually differentiate. So if y equals 2x squared plus 5, our gradient function for this curve, multiplied by the power and bring the power down by 1, is 4x. So if the point P is 213, I can substitute in at the point P, so the gradient at the point P is 4 lots of 2, which is in fact 8. So it says find the gradient of the tangent to the curve at P. Perfect. We've done that. Then at the point Q with the x-coordinate 2 plus h. Okay, so if we're assuming here that h is positive, 2 plus h would be anywhere above P, essentially, and it lies on the curve. Find in terms of h the gradient of the line PQ. Give your answer in its simplest form. So let's imagine it is here. So Q, so we know that our x-coordinate is 2 plus h. Okay. And then we know our y-coordinate is, if I substitute in 2 plus h into our x, so y equals 2 lots of 2 plus h squared plus 5, which is going to give me 2 lots of h squared plus 4, h plus 4, then plus 5, which is going to give me 2h squared plus 8h plus 8 plus 5 is plus 13. So then I'm going to have my y coordinate 2h squared plus 8h plus 13. How do I find the gradient? Well, nice and easy. y2 minus y1 over x2 minus x1. In this case, my coordinate of y2 is in fact my q. So we're going to have 2h squared plus 8h plus 13 minus 13 over 2 plus h minus 2. So on the numerator, we know our 13s are going to cancel, our 2's are going to cancel, and we can actually then divide everything by h. So we're going to be left with 2h plus 8. So this is the gradient of the line PQ. Part C. Explain briefly the relationship between the answer to B and the answer to A. So, as we have an unknown h, we can always say, this part C, as h tends to 0, the gradient of PQ tends to 8, which in fact is the same as the gradient of the tangent at P, because actually that's the same as that. Okay, I think if we check the mark scheme, yeah, we do need to at least write a limit, and we do need to connect A and B together, which is great. Question 8. Solve using algebra the equation x minus 6x to the power of a half plus 4 equals 0. Okay, what am I thinking about? Hidden quadratic. So, fully simplify your answer, writing them in the form a plus b root c, where a, b and c are integers to be found. So, first of all, we know that x can be written as x to the half squared minus 6 x to the half plus 4 equals 0. So I'm going to let y equal x to the power of a half. So if y equals x to the power of a half, we're going to have y squared minus 6y plus 4 equals 0. I'm then going to solve this, and I'm going to get y equals, when I've put it into the calculator, 3 plus or minus root 5. Okay, we haven't finished there though, because that means that x to the power of a half equals 3 plus root 5, and x to the power of a half equals 3 minus root 5. How do we get rid of a power of a half? We square both sides, and then we will be left with x. Now in this case, because we're squaring, we're actually going to have x equals 3 plus root 5 all squared. Now, this 3 plus root 5 squared, if you wanted to, you can expand the brackets. So please do this or type it into your calculator. It's going to have 9 plus 5 plus 3 root 5 plus 3 root 5 is going to give me 14 plus 6 root 5. So we're going to have 14 plus 6 root 5. And again, I know this is going to be the same, apart from we're going to have a negative. So x equals 14 minus 6 root 5. And there we go. We've solved it. We've actually done it without using, we did use a calculator for this, but actually. Okay, but you can see all the step-by-steps. Okay, question 9. So figure 5 shows a sketch of part of the curve with the equation y equals sine x over 12, where x is measured in radians. Okay, step 1, calculate it in radians. The point M, shown in figure 5, is a minimum point on C. State the period of C. Okay. What does it mean by state the period of C? Okay. Well, we know, first of all, let's break down. So we know figure 5 shows a sketch of part of the curve C with equation y equals sine x over 12. So if we think about this in terms of f of x equals, and what have we done to x in this case? We've divided it by 12. Okay, so is it inside or outside the bracket? It's inside, it affects x. What are we going to do? We're going to multiply our x coordinates by 12. We know that a normal period of the sine graph, which is what we're used to, starts at 0 and finishes at 2 pi. This is what we call one period. For C, what we've done, our C is, we've done a transformation. So we've actually multiplied all of our x coordinates by 12. So that means now our period of C, this coordinate here will no longer be at 2 pi. It will be at 2 pi multiplied by 12, because what we've done is it's a huge stretch. So the period will actually finish at 2 pi times 12, which is 24 pi. So for A, we have 24 pi. Part B. So state the coordinates of M. All we've done in our transformation, it affects only the x-axis. We haven't done anything to affect our y. So we still know that this is 1. We still know that this is minus 1. But this coordinate here would normally be 3 pi over 2. And if we multiplied it by 12, we're actually going to get 18 pi. So 18 pi and minus 1. Next part of the question. The smallest positive solution of the equation sine of x over 12 equals k, where k is constant, is a. So here we have k. We want to find a. Find in terms of alpha the negative solution of the equation sine of x over 12 equals k that is closest to 0. And the smallest positive solution of the equation cos of x over 12 equals k. Okay, so we've got a few things going on here. So, again, I always like to refer to the original graph. So if we want the negative solution of the equation that is closest to 0, if we just carried on drawing this graph, our k would in fact be here. Now we know from symmetry that we know that this is pi. So this is minus pi. But again, remember we've transformed the graph, multiplied everything by 12. So this is actually 12 pi. This is minus 12 pi, this coordinate. And then we're not sure of our angle, but we know it's alpha here. So we would actually then have to take away alpha. So for the first one, we're going to have minus 12 pi minus alpha. Part C, II. So if you think the smallest possible solution of the equation cos of x over 12, if we were to draw the cos graph, and again we need to multiply all of our x coordinates by 12. So we know that cos cuts, comes down and up. So we know this is 1 minus 1. We know now that this is 12 pi, so it essentially would be pi. This is 6 pi, 18 pi, and 24 pi. Okay, our value for k is here. So if we go across, we're actually going to get 6 pi minus alpha, because remember, our k is going to be here as well. So 6 pi minus alpha is going to give us our solution. So the answer is 6 pi minus alpha. And again, when you're unsure, so when in doubt, draw it out. Question number 10. Figure 6 shows a sketch of part of the curve with the equation y equals f of x, where 2x plus 5 and x minus 3 squared. Deduce the values of x for which f of x is less than or equal to 0. So where is x? Where is the equation f of x less than or equal to 0? Well, it's anything below the x-axis, and because it says less than or equal to, I'm going to have this point here, or anything to the left of this number. Now, from the graph, we know that our solutions are minus 5 over 2, and x equals 3 is an equal root. So that means here, we're going to have then, deduce the values for where this is less than or equal to 0. This is when x equals 3 or x is less than or equal to minus 5 over 2. Part B. The curve crosses the y-axis at the point P as shown. Expand f of x to the form where a, b, and c are integers to be found. So this is a nice, easy expansion. Again, you should be able to do this from GCSE. And then we're going to have x minus 3, x minus 3. Personally, I'm going to expand these two brackets first. So I'm going to have x squared minus 6x plus 9. I'm going to multiply everything by 2x. So 2x cubed minus 12x plus 18x. Sorry, that's a squared. Now multiply everything by 5. 5x squared minus 30x plus 45. I'm now going to make sure that I simplify this. So I'm going to have 2x cubed minus 7x squared minus 12x plus 45. And there we go, we have it in that form. Part C says, hence or otherwise find the coordinates of P. So P is where it crosses the y-axis. So this is when x equals 0. Y equals 45. This is our y-intercept. So we're going to have 0, 45. Part C says the gradient of the curve at P. Well, to find the gradient, sorry, this is CI. To find the gradient at a specific point on a curve, I know I'm going to differentiate to find my gradient function. So we have our y equals, if I differentiate this, I'm going to get my gradient function. Bring the power down, 2 times 3 is 6, x, decrease the power by 1. Minus 7 times 2 is minus 14, decrease the power by 1. And we're going to have minus 12. If I substitute in there my x coordinate of 0, my gradient is therefore minus 12. And then part D, I, Find g of x given your answer in a simplified factorized form. Oh, wait there, I missed part of the question. Right, the curve with the equation y equals f of x is translated 2 units in the positive x direction to a curve with the equation g of x. So it's translated 2 units to the right. So essentially we've added 2, but we know then that g of x is actually f of x minus 2, because we do the opposite of what it says in the bracket. So instead of writing x into our original f of x, I'm going to have g of x equals 2 lots of x minus 2 plus 5. And then I'm going to have x minus 2 minus 3 all squared. I can simplify that to have 2x minus 4 plus 5 is in fact 2x plus 1. And then x minus 2 minus 3 is x minus 5 all squared. And then part D, II says, hence state the y-intercept of the curve with the equation g of x. Well, to find the y-intercept, I'm going to do all of the numbers multiplied by each other. For example, what I mean by that is if you was to expand this, you'd get 2x plus 1, x minus 5, x minus 5. The only way to get the y-intercept is to do minus 5 times minus 5, which is positive 25 times 1. So it is in actual fact, the y-intercept is 25. Question 11. A curve has equation y equals f of x. The point P, 4, 32 over 3, lies on the curve. Given that f dash dash of x equals 4 over root 5 minus 3, and f dash of x equals 5 at P, find the equation of the tangent to the curve at P, writing your answer in the form y equals mx plus c, where m and c are constants to be found. So, for part A, we want the equation of the tangent to the curve at P. So, we know the gradient at P is 5, and we know the point, which is 432 over 3. So I'm going to have y equals mx plus c, 32 over 3 equals 5 lots of 4 plus c, so 32 minus 20 is going to give me minus 28 over 3. So therefore, y equals 5x minus 28 over 3. So that was nice and easy. And then part B, find f of x. Okay, so I'm going to have to integrate twice because they've given us the double differential, and also make sure I'm finding my constant of integration. Okay, so I'm going to start up here. Okay, first of all, so this is 2y by dx squared equals 4x to the power of negative a half minus 3. Okay, so if I integrate this, I'm going to get dy by dx. So dy by dx equals 4x to the power of minus a half. Okay, when we integrate, we increase the power by 1, which gives us a half, and divide by the new power. 4 divided by a half, 8. Increase the power by 1, becomes x, divide by the new power, which is just 1. Then our constant of integration plus c. Now, lucky for us, we know when x equals 4, our gradient equals 5, because we were told that in the question earlier. So we know that 5 equals 8 lots of 4 to the power of a half minus 3 lots of 4 plus c. So 4 times 2 is 16, minus 12 is 4. 5 minus 4 is 1, so c equals 1. So now I know that dy by dx equals 8x to the half minus 3x plus 1. Now to find out what y equals, or in this case f of x, we need to integrate this with respect to x. So increase the power by 1, 3 over 2, divide by the new power. 8 divided by 3 over 2 is 16 over 3. Increase the power by 1, x squared, divide by the new power, 3 over 2. Increase the power by 1, x, plus our constant of integration, c. Now, what do we know? Now again, using the fact that this point lies on the curve, we know that when x equals 4, y equals 32 over 3. So I can use that point to substitute in. So I then know 32 over 3 equals 16 over 3 lots of 4 to the power of 3 over 2 minus 3 over 2 lots of 4 to the power of 2 plus 4 plus c. When I rearrange this, I get c equals minus 12. Therefore, the final answer is f of x equals 16 over 3x to the power of 3 over 2 minus 3 over 2x squared plus x minus 12. And actually, I think that was quite a lovely question for 8 marks. So again, thank you for watching this. If you have any questions, just put it in the comments. But if you don't know how to do certain topics, please watch the videos on the chapters. Have a lovely day.